Where would we be without the weird and wonderful materials all around us? Plastics, metals, textiles, wood, stone, they all go into the endless variety of stuff available to us. But do our materials choices have to change in the 21st century? Join us to find out. Welcome to the Diff. It's the penultimate day of the 2016 Disruptive Innovation Festival, but there's still loads left to see and do. And today we're talking all about materials. So if you've been coming to a few Diff sessions, you've probably heard a bit about the circular economy. By this we mean moving from a take, make, dispose way of doing things to a new model that's regenerative and restorative by design. And if we're thinking about developing a circular economy, then rethinking materials is a vital building block. And to help us out on this exploration today, we've got Eric Lochtens in the studio. He's of Noble Environmental, and he'll be telling us all about Ecor, which we'll hear more about later on. We're also joined by Mark Miodownik online. Mark's a professor of materials and society at UCL. He's the author of Stuff Matters and a two-time Diff speaker. Also joining us in the studio is Karen, who'll be looking out for all your questions today.
That's correct, Joe. Actually, if you want to pose your questions to Mark and Eric, please use the chat below this video or using the hashtag ThinkDiff in Twitter at ThinkDiff.
Thank you, Karen. Yes, don't forget to send your questions in. But firstly, Eric, I've got a question for you. Ecor, what is it?
Well, Joe, Ecor is made with only water, pressure and heat. And we can convert almost any kind of cellulose fibers into a panel. And from that panel you can make structures, you can bend it, you can laser cut it, you can print it, as you can see on the panel behind you.
So this is Ecor panels that we have behind us in the Diff studio. We've had them here for
Yes.
3 weeks.
Yeah, so these are made of old office paper, the office paper. And to give you an example, here on this table which we made for Ellen MacArthur, we did an R&D on converting coffee grounds into a panel, and with water pressure and heat we could hear. And we've got a couple of samples like Ecor made out of wheat straw, Ecor made out of cotton, and so on and so on. So the cellulose fibers we can take, the blends, the recipes we can make, those are essential. And the applications you can find in building and construction, signage and display, consumer products, whatever.
So we're going to talk a bit more about the applications in a couple of minutes, but just a bit more on the product. So cellulose fibers.
Yes.
Paper is one source of those that you mentioned, but where are those coming from mostly?
Yeah, well, we define them in urban fibers, farm fibers and forest fibers. Forest is more obvious, it's like wood chips from the wood manufacturing industry. Farm fibers, you must think of almost any kind of crop after the harvesting. So like corn, wheat straw, whatever. Urban fibers, you can think of all newspaper, corrugated cardboard, jeans, the coffee grounds which I was talking about. So it can vary a lot. And what we do is we develop this technology in over more than a decade. And after that we started with a pilot factory in order to see if it's also upscalable. Is it got viable? Do we really recycle 99% of our water? What energy do we use? What are the effects of 24/7 versus 5 days a week with 8 hours? And when I was thinking on what is the route to market for this, because the applications can be almost everywhere, we decided to develop a community of designers, which could be like an architect or a product developer or any kinds of design. But what you also need is people who make this, who start putting bolts in it, laser cut it, print with it. And with these communities, we enable them to achieve their circular economy ambitions.
So you've got
that's
designers, architects experimenting with this material.
Yes.
And just to go back on that point about what goes into it, it sounds like that's stuff that would have been wasted otherwise. I mean, coffee grounds, we hear about a few uses for them, but there's not many people doing much with that, is there?
For me, cellulose is waste. It's just a material without a label or a certification. So, of course, we need to go in the R&D. So it's about co-creation, taking co-responsibility, cooperation, and from there on, you can develop these recipes, and these recipes where you need to facilitate also this collaboration. And that's why with Van Houten we decided to go to an R&D facility in the Netherlands now.
Okay.
Yeah.
And you've been working on it for a few years, you said. Would you say 2002 or?
Technology took us 10 years to develop, because the moment we said it's about doing the right thing and it's only water, pressure and heat, no additives, no glues, no whatsoever, that took the 90% of that time. And now, about 2 years ago, we started to commercialize this product and put it into different projects, different applications into the market with governments, commercial companies, and so on and so on.
And why do you think now people are getting interested in materials like this?
Well, personally, I've been involved in critical product design and commercializing critical products for more than a decade. And I think circular economy on itself also is about a behavioral change. And people know now, they want now, but the next step is that you need to go out and start doing it. And I think technologies like ours are the ones who will enable others to achieve their ambitions. Yeah.
So it's
that momentum is right now.
Well, that's what I was going to say. Momentum from other companies is something that's maybe supporting the growth of the scalability of Ecor.
Yeah, the path of knowing what you can do, the part of wanting, the political will is there. I can see in larger parts of the world where I work in, and I think that there is enough momentum now to really make a meaningful difference together.
And so we have this momentum. There's this growing interest. How would a business use it? We've seen panels, coffee table here. Two possible examples. Are there? I mean, you made it sound like it's almost endless, the different applications of this product.
Yes, and that's immediately also the biggest threat, of course, because you can't label or put it in a box. But let me make it very obvious by some examples of projects we are working now on. So in April of this year, I met Ricardo Weigand from Heineken Mexico at the accelerator workshop of LMCATA. And now in 6 months' time, we grew in a collaboration where we signed a 3 years collaborative research and development agreement. We defined 4 projects with Heineken as a pilot project. And it's all about converting their beer industry waste streams, cellulose waste streams, into applications they can use in their materials. So think like promotional activities, packaging activities, and so on and so on. So we're in prototyping with them, and it's very exciting news.
Heineken Mexico, you met them at a CE100 acceleration workshop. So for audience that don't know, Ecor, a member of this network of businesses working towards a circular economy. So you met Heineken, and that's a pretty big company. So they must be taking it seriously if they're investing in this new technology.
Yeah, well, but it's also a good business and good sense. It has got an impact from an environmental perspective. But to give an example, we are working on a promotional activity they use in thousands of settlements where their products are sold. And it's like a sign, and that sign will be exchanged over time and there's a repetitive material in it. Nowadays they use like a PVC former for this material. With using their cellulose waste stream, we convert it into an Ecor panel. On that Ecor panel they can print it, and instead of using the PVC screen only once and then after a couple of weeks it is discarded, we now have we can take the reverse logistics, take this panel back, put it in our blender again, make a new panel of it, and then it'll be the promotional activity for the next cycle. This will mean that there's no purchasing of raw materials again over and over. It means that they can use their own waste streams, which are upcycled. We create added value to this, and it will have an impact also on the perceptions of the brand and the positioning of this brand. So there are so many examples of what we're working with and what we're introducing. May I use another example?
I think we're just going to take we hold that thought.
Okay.
We have a question, hopefully from the audience watching online. Karen, who's getting in touch?
Yeah, so Milena she has a question for Eric. Actually, Milena, I've seen she's very active this year in the DIF. She has watched a lot of sessions, and I can see her comments in different sessions, which is quite nice. So she said, like, you focus on materials, yes, but she thinks design is fundamental to make actually the use of materials more efficient, yes, and waste materials more efficient. She's a designer, and she says that when she designs first, she thinks in the outline of the design, and then she thinks in which kind of materials she can use to make it real, to make it happen, to create them. So her question is, do you think we should think design the other way around? Like first look at the materials and see their possibilities, what we can create with them, and departing from the materials, we should design our things?
Well, we said it like Ecor is a license to think outside of the box. So let me give you an example. When we started about 1.5 years ago, there was a project for a hair salon, and this project was completely designed. All the materials, the aspects, the veneers, and so on. And we went into Ecor being inside, so like a replacement for MDF or particle board. And this was, when you now walk into this hair salon, it looks like every other hair salon. It's a beautiful hair salon. But what this designer then learned is to look on the aspects of the material itself. What about weight? The fact that you can laser cut it, the fact that you can CNC phrase it. So it led him to think about the topic on weight. So he then used the aspects of the material to design a product, in this specific case a chair, where weight was the most predominant factor because it was on terraces outside, and it would take less labor to get these in, day out. So yes, I completely agree, is that you take the material on itself and the basics on itself to start from designing it from there. That's also what I meant with the community of designers. Let people come in, let them go explore, and let them see the new opportunities of the material at hand, the aspects, how it feels, how it sees. Because when you give me as a waste stream only aubergines, you will get a purple Ecor. Yeah? So it's that's why.
Given you aubergines as a waste stream?
Not till today.
Not yet.
Not yet.
Not today. Yeah, many different ones.
Thanks, Karen. You did have another example that you wanted to mention.
Yeah, I like to make things very practical and pragmatic. So to give an example is with Schiphol Airport in the Netherlands. I met Jeremy Cruz, also via the C100, and we set out on a project which we faced. And the first phase was we made it very simple, very tangible, and that's building shots. So like when you're renovating an airport, you, as a traveler, you walk past these building shots. And that project, the first phase was, can we do it with technical, with the existing Ecor made out of beverage cartons and old office paper. So can you put a door in it? Can you put hinges? Can travelers go secretly behind the customs and all that kind of stuff? And in a couple of weeks' time, we will launch in this terminal this first building shot, where basically we replaced formaldehyde and phenol glues, MDF out of that. The second phase was that we went out and searched for race materials from Schiphol, which could live up to the specific technical demands and program of demands of the building shot itself. And we came up with miscanthus, it's like, how do you say in English? Elephant grass. And beverage cartons which the travelers throw away in the terminal. We made an Ecor recipe, a Schiphol Ecor alloy with them. And now that Schiphol Ecor alloy is ready. So we've proven the case that we can do this. And the next phase is that you then go to upscaling this by taking it into manufacturing. So we take the wet streams of Schiphol, we take the old building shots, we take them back, put them in the blender, make a new Ecor panel out of it, and then make these materials really circular, where normally they would discard them every time there was a new renovation. Projects like that.
So two big examples there, and I'm sure you've got many more that you could share with us. We're going to come back to some of that. We're going to speak to Mark in a few minutes around some of these big picture questions around the materials we use. But it's the penultimate day of the diff. And if you head to the Catchup pages now, there's an almost overwhelming amount of stuff to watch and to rewatch in those Catchup pages. So to help guide you through that mass of stuff, here's Nora.
Thanks, Joe. Yes, so there are just 2 days left of live broadcasting here at the Diff. So let's just have a look at a selection of some of the sessions coming up today. So first up, at 1 o'clock and with Martin Crawford, we will be looking to learn some lessons from the forest. And Martin is a forest gardener practitioner, and he will be telling us why we should be taking inspiration from the natural world to create conditions more conducive to food production. Up at 6 o'clock, we have an open mic session from Thomas Leach, who is a student at the Royal College of Art in London. And Thomas will be showcasing his work on a shoe project where he has taken cut-offs from the leather industry and created and developed a new range of children's shoes. And of course, remember that you can catch up on all of the sessions that we have had here on the Diff for the next 30 days, and you can do so by creating a Diff account. Some great sessions, or a great session I should say, to catch up on from yesterday was a session called The Rise of Digital Technology featuring Douglas Rushkoff, and he talks about why he reckons the digital revolution hasn't delivered on what it promised. Remember, Diff is all about interaction, so if you see any graphics on the session pages, please click on them and write in your comments about the sessions itself. We would love to hear from you. And last but not least, Twitter is a great way to get the conversation going. Please do get on there and tell us your thoughts at #ThinkDiff. So that's all from me, and I'll hand back over to you, Joe.
Thank you, Nora. That session with Douglas Rushkoff last night was a cracker. It got Twitter absolutely buzzing. So I echo Nora's statement. Go and catch that one on the Catchup pages. Karen, any questions coming in that you'd like to share so far?
Yes, actually I have another one coming from our social media to Eric. What is the weirdest waste material you have used to create a product?
This wasn't set up, but I've got something here. This is second-hand toilet paper.
Okay.
So basically, with this fantastic guy, Marco Kwak from Tarot, that's a Dutch waste management firm, via Scandinavian technology, they were able to filter the cellulose fibers out of the sewage water, which built a tremendous business case because cellulose fibers into the water purification systems take up almost 25% of the capacity. So when you can decrease that, it's an enormous economical value. But then you've got the cellulose fibers and what you're going to do with it. So I got the question from Atero together with a couple of water reservancies in the Netherlands. Can you make a panel out of this? So we got these second-hand cellulose fibers, made a panel out of that. And what we are now researching for is how these water reservancies can then reuse them. For example, when they pour concrete for like the building shapes, I don't know how do you say it in English? The foundations, that we use the cellulose panels, the Ecor panels, to pour them in, so they don't have to take out the wood material in the building process, so it decreases it, and then the cellulose will be filtration to the soil again. So I think that's about the weirdest one I had till today. Yeah.
Well, to look at some other weird and wonderful materials stories, we're joined from the Institute of Making by Mark Miodownik. Hello, Mark.
Hello.
Thanks for waiting patiently in the background. And I'd like to talk to you about some of these bigger questions around materials and the way that materials flow in our economy. But just to kind of frame the discussion as a starter, you've mentioned in the past that we only need to look around ourselves and the materials we created to understand our needs as humans. What did you mean by that?
I think you look around. If everyone looks around where they're sitting now, or standing, or the wealth of materials that is easily spots. I got a bottle here and a lamp here. Wearing clothes, it's just amazing. I mean, and where did all those materials come from? Why do we need so many of them? And my thesis has been that they represent something about us. Like when you look at the material world, you're looking at us. It's a mirror of our values, who we are. And so you only have to question, what any one of those objects, any one of those materials, to see that we are very multifaceted as a civilization. We want lots of stuff. We need shelter. We need food. We need comfort. We need imagination. We love to travel, so we invent alloys to fly. And so all of this stuff, in my view, is an expression of who we are and what our values are. And of course, one of the biggest indicators of our values is to look where the stuff ends up at the end. And it usually ends up in a hole in the ground. And that kind of tells you something else about us, which is that we kind of haven't thought it through. We're not kind of holistic in our worldview.
Well, you're definitely touching on a big theme of this session. So you obviously, in your position at the Institute of Making, with the materials library there, which we'll mention about in a moment, you obviously know a lot about materials and have a real passion for them, but also about the circular economy as well. I know you've looked at some of the points around the circular economy as part of a MOOC that you've done with UCL. How can material science help us begin to address some of these challenges in moving from a take, make, dispose economy, which you just described, to something that's more restorative, more regenerative?
Yeah, well, I think all of these questions. Eric was just talking about developing a new material, and it's a really exciting material for the circular economy. And the questions, all of that research bit that is required to get a material that actually functions to requires an understanding not just of design and of people's, the aesthetic qualities of the materials, but of the fundamental engineering and science behind making the properties. So, are they in that case without giving off toxic fumes? And I think all of those questions, of course, that's where the science comes in. And science is not the whole deal, but it's a vital part of any transition to a circular economy, because we've got all these new materials because in the 20th century, which is where the big explosion of materiality came, plastics and semiconductors and computational materials and flat screens and touch screens, all that stuff has come from an explosion of knowledge of material science. But one thing we didn't do while discovering all these new novel materials was really think about their end of life. And I think so that bit of research about how materials then become part of a circular economy is just not being done in material science departments or engineering departments or chemistry departments. I mean, largely, there are some exceptions, but largely it's just not being done.
And new materials are important and exciting, but I know steel is one of your favourite materials, and one that you feel has some properties that make it a really good example of how a material can be circular or can remain in flow.
Yeah, I mean, steel is a very, it's been vital for the economy, and it, of course, was underpinned the Industrial Revolution. by being able to make steel cheaply and mass produce steel, we then were able to make things like railways and the infrastructure you see around you, all the cars, buses, trains, they're all made of steel, obviously. And so you might ask yourself, well, what happens at the end of the life of those objects? But actually, it's been quite a success story, partly because of governments like the EU kind of pushing recyclability of it. So you have 90% of a car, the steel component of the car is recycled now. And also because of the material itself, it actually really suits being recycled because it's easy to recover from a heap, because you can get a magnet out. And I mean, not all steel is magnetic, but a vast majority of them are. And so you can quite quickly recover them. And then actually the energy required to make them into new steel products, although appreciable, is much lower than taking it from raw ore. So steel is already, there's a huge amount of scrap that goes back into the steel process. And in fact, the calculations that people have done are that we've probably already smelted enough steel from ore for the whole world's needs. So actually going forward, and when you look at the price of steel and the problems with the steel economy at the moment, it's mostly to do with oversupply. So that in a way, there's a big opportunity there for a next step in terms of the circular economy of steel products, which is that for most producers to go towards remelting steel scrap as their major source of steel.
Thank you, Mark. Sorry, just hearing myself a little bit there, but we'll try and carry on with this. Can you tell us a little bit about the materials library and the Institute of Making? So that was something you focused on last year at the Disruptive Innovation Festival. For those that don't know, as we move on to discuss what you've been up to more recently, what is the Institute of Making?
The Institute of Making is a place where we bring together different disciplines to understand and build prototypes of new materials technologies. We're based in the UCL, and any member of UCL staff or student body or the professional services can join us. So we don't care whether you're interested in using the sewing machines that we've got, or using the kilns we've got, or whether you're using our laser cutters or using any of our machines. We think that pretty much everyone and every subject in a university has something to say about the made world, and that has proved to be the truth. So we have more than 2,000 members from the UCL who use our facilities, and actually it was a big surprise to us in a way. We thought that there'd be people from architecture and people from design and people from engineering. We thought those people would turn up, but actually we have people from anthropology, archaeology, we have people from English and history, we have. And those people, we have the librarians. So we had a robotic challenge last year where we taught people how to make robots, and then we had a robotic competition. And the people who won it were the librarians. So I think what it tells you is that people are starved of the ability to make things. They're starved of access to workshops and materials, and that they really not just want to be involved because it is part of who we are, as I said before, but they feel compelled to be involved.
And that speaks to Eric's piece from earlier about a location where people can get hands-on with Ecor and start experimenting. I've been to the Institute of Making a couple of times. It is a fascinating place. What's new, Mark? What's been happening in the past year?
Yeah, we've got a lot of new stuff going on. One of the things I wanted to talk about was a new project which we've got with a few universities in the UK, Leeds University, Southampton University, Birmingham University, and a lot of manufacturing companies around the idea of self-repairing cities. So it turns out, of course, that if you kind of look to the future, that more and more people will end up living in cities. That's a more ecological way to live from an energy footprint, and also people enjoy living in cities from a sort of social perspective, from an opportunities perspective. But actually infrastructure is a big problem because by and large, what we tend to do with infrastructure is kind of put it in place, and then when it kind of breaks down, we then dig it up and replace it. And that causes a lot of problems in cities. And so things like pipes and your internet connection, water, gas, electricity, the road system, the rail system, all of these things are constantly decaying and constantly, and then of course you have global warming, which in certain areas causes flooding, and that then wipes out whole bits of the infrastructure. And so the way this project is set up is to investigate whether by 2050 we could develop materials and systems in cities where the infrastructure is totally self-repairing, that it repairs itself autonomously.
That sounds amazing and is very relevant for one of our themes at the DIF, which is regenerative cities. I can think of almost nothing more regenerative than a building or infrastructure that heals itself. Where can people find out more about this, Mark?
We got all the information on our website, institutemaking.org.uk, and that also shows you some of the other major projects that we're involved with. So we've got another project called Hands of X, which is about the idea of making prosthetics and mobility aids from materials which the users choose. So instead of being given a prosthetic with maybe a limited range of materials which you may not feel represents who you are, like silicone rubber or even carbon fiber, which are two kind of there's the high-tech option and the kind of and similar to skin option that you kind of get offered in today's healthcare environment. And we're interested in people being able to kind of design their own prosthetic, but being able to do so in an economically realistic way, of having bespoke material that they feel represents them, or several materials. And that's called Hands of X. That's also information on our website. If you want to get involved, please get in contact.
So a few great projects going on in the Institute of Making. Karen, I believe we've got a question coming in for Mark from the audience.
I have a question from the session page. David is asking, Mark, the drivers of circular change. Can you highlight the risk, challenges and opportunities of critical materials?
So one of the issues, obviously, in material supply chains for things like a smartphone. I mean, obviously, smartphones obviously bring a lot of happiness to people and also economic opportunity and social vibrancy. But the average smartphone has half the periodic table in it. So that's about 50 different elements. And so imagine where they come from. Well, they come from mines all around the world, and they are, so there's at least 50 mines, probably more, probably 200 different mines. All of those supply chains have to kind of find their way to the different component manufacturers, and then those component manufacturers then supply them to the main mobile phone assembly points. So we're talking about things like indium. Indium is quite a rare material in terms of its kind of abundance in the Earth's crust. It's very important for smartphones because the touchscreen is based on that technology. It's called indium tin oxide, and what its claim to fame is that it's a transparent conductor. So you can't see that your screen has a grid of conductors on it because it's transparent, but it does, and that stuff is called indium tin oxide. So without it, the touchability of screens is no longer possible with the current technology, and yet of course this stuff is not very plentiful, and at the end of its life, those touchscreens just go into a hole in the ground. So that's just one example, indium. But if you look at the periodic table and how many of the elements we now rely on, there's an increasing number of those elements that appear to be, going to probably be limited by supply. We had an example a few years ago of where neodymium, which is another material which actually is called a rare earth. What it is a very highly valuable material for magnetic applications. It's got this high magnetic permeability. So it's used for things like very efficient motors. You'll find it in electric cars, for instance. And when the electric car industry started to increase and neodymium was more and more in demand, and also wind turbines, then the supplies got short, and most of the neodymium, I think almost 100% of it, was coming from China, who then restricted supply for a while because they wanted it for their own industries. And now there are mines opening up all over the world for neodymium. It's not that rare, but this shows another aspect of the problem, which is that it takes years to open a mine, and it doesn't take very long to close a mine. So what happens is with these industries is that you get a spurt of interest in a technology which requires a particular material. You get a whole community being built around that mine, and then if the price suddenly drops because of oversupply, that community is then devastated. And I think that's the other aspect of this, which is that it's not just about where the materials are in the world, and it's the reliance, and I think especially in the current political climate, the reliance on the world being a globalized economy, which will always give you the ingredients that you rely on for, let's say, your medical technology or your communication technology. That assumption, for me, feels not a very reliable assumption going ahead into the future.
So those are a couple of challenges. I think I was also thinking opportunity there as well. With when we're faced with those challenges, there could be opportunity to experiment or rethink more around the materials that might be in short supply. Karen, I know you had another question there for Eric.
Yes, I have a question for Eric, also from our session page. David is also asking, how much would shifting tax into primary materials help use more secondary materials?
Yeah, so basically to lower the taxes on labor and increase the taxes on the products based on their added value or their bad value. I think it would help a lot because when we build these business cases now with companies on exchanging into Ecor and so on, we're asking the broader questions. What is the CO2 impact? What is what's the impact of discarding all the time, and where we can keep them in the cycle? And the true costs are not really taken into consideration normally. So we tend to want to design for refurbishment and for reuse with the designers, and we see the increase of value, but it's not a real general market appreciation for that material. But I think for Ecor to have an impact on that one as well, it comes a little bit too early. Yeah.
Thanks. I've got one more question for both of you. We've heard about a new material, Ecor, that's being used, and obviously materials innovation is a very popular area. There's been many other sessions at the DIF about new materials. Biomimicry is another popular topic. Biomimicry advocates would say, in nature we use less materials. There's only there are far less materials used in natural systems than we do in the world around us. So how do you manage that tension? That there's new materials that offer benefits, but it does mean there's more to sort out at the end of life.
Well, I think in essence, we're not using more materials. We are simply going to the basis of what cellulose is, which is everywhere. And we use clean manufacturing technology. And from there on, we go into different applications. And once we can keep the integrity of the material during this user cycle, so not a life cycle, but a user cycle, then we can reconvert it over and over again. So I actually think that we're providing with the technology, we're providing the lesser use of material at the end of the day, because it's every day.
Any thoughts on that one, Mark?
Yeah, I mean, so we have a centre here called the Centre for Nature Inspired Engineering at UCL, and we do a lot of work in this area. And I don't think it's an either-or situation. I think that there's a lot to be learned from, of course, the way nature does things. And in fact, of course, people are using natural systems to grow materials. You know, so you've got a lot of packaging materials based on fungi and that sort of thing. I mean, my prediction is that, so the reason why the rest of the periodic table is useful, I mean, given that nature uses carbon, nitrogen, oxygen, hydrogen mostly, and a few trace elements to kind of build everything else, which is pretty impressive, you have to say, wood and cellulose and teeth and hair It is pretty impressive, but it does limit the human kind of, let's say, experience a bit if you want to go into space or you want to kind of have an aircraft and go very fast. And I guess we're back to the thing about who humans are and what we want to do. And I think our expression of wanting to go places fast, get in an aircraft, for instance, or go to the moon, that compels us to use the other elements, because I don't think we're going to be able to do those things just based on.
We've lost you
My
for a moment
prediction
there,
is
Mark.
that as we get into the 21st century, that the difference between what we call an animate material and an inanimate material is going to disappear. That we're going to have more and more animate materials that we design, which will have interlocking bits of biology. So I think our homes, our cities, instead of biology being an add-on, a park or a nice little window box, I think our biological systems to create biofuels, to collect energy from the sun, will be integrated into our cities. And I think understanding the interface between the sort of, let's say, the non-living material systems and the living material systems, that's going to be really interesting.
That's definitely a compelling vision, and one that I would nearly end on if it wasn't time to play a game that I have invented. Anyone who's been watching Diff so far knows that I am a fiend for some on-air games. It's the penultimate day of Diff, so to celebrate some of this discussion around materials and the variety of materials, here's a game that we call Real or Fake.
Real or fake?
Fantastic. High production values on the session, as always. So this game works relatively simply. I'm going to name a material, and my panel here have to guess whether it's a real material or whether it's a fake material. Everyone understand?
Yes.
Okay, first up, adamantium. Okay, so Mark, we'll go with you first. Adamantium.
Adamantium. I think it's real. Mineral.
Okay. Eric?
Yeah, I agree.
Okay, copied.
It's real.
3 real for adamantium.
I'm going to follow Mark on every
Of course, it's false. It's not real. That's what was fused to Wolverine's skeleton in the Marvel universe. So you've dropped the ball on that one. Next up, second real or fake. One-way bulletproof glass. Eric.
Fake.
Karen. Karen's gone with real. Mark.
Real.
It is real. You can Google it. One-way bulletproof glass. I'm not going to try it out, but apparently it does exist. Okay, we've got 3 left to go. Transparent concrete. Karen.
Fake, soon to be real.
Fake, soon to be real. Okay. Mark.
Real. We've got some.
Dead giveaway, Mark. You've given that one away. Eric, what do you think? Do you reckon that's real?
I guess real then.
You think that one's real?
Yeah.
Correct. That one's real. I've seen it. Transparent concrete. Very interesting material. Next up. This one's for you, Mark. Sub-aqua cheese.
Oh my god. I hope it's fake, is all I can say.
Okay, gone with fake. Eric?
Gambling again. Fake.
Gone fake. Karen?
Real.
Sub-aqua cheese, not real, I'm afraid, although some Canadian explorers did find a large block of cheddar in the ocean once. They hauled it up, but it wasn't edible, I'm afraid. So that one is a fake. And then lastly, aerogel. Eric?
Well, that sounds to me as real.
Okay, Karen?
Real.
And Mark?
It is real, although it's the most alien thing I've ever seen in my life.
Can you tell us a little bit about it, Mark? What is it?
It wasn't until recently the lightest material ever created by humans, 99.8% air. It looks like, it's called frozen smoke often by people because it doesn't look like a real material. It doesn't look really solid. It looks like some sort of gas that's somehow created into sort of ghost-like material. It's very, very odd.
It's quite amazing stuff. And on that wonderful celebration of all the wonderful materials around us, I'd like to thank the panel for joining me today, Eric and Mark and Karen, for your fantastic questions. Thank you, everyone.
Thank you.
Brilliant. Yeah, thanks.
That was one of my last sessions at the Diff this year. But do remember to tune in tomorrow for the Diff Grand Finale. It'll be the last session from the studio here at Disruptive Innovation Festival 2016. It's on at 5 p.m. And it's bound to be fun with lots of clips and highlights from this year's festival. But for now, thank you for joining me on this journey through the world of materials around us. We'll see you next time at the Diff. Bye-bye.